In this video, we are going to talk about how to solve a one-step addition equation using an inverse operations. All right, so when solving equations, your overall goal is to get the variable by itself. So you want to undo the addition of 19. So what you want to do is use an inverse operation. And the inverse operation of addition is subtraction. So a lot of people will say that an equation is much like a balance scale, where you draw your balance scale right where that equal sign is. And on this side of the balance scale, we have x plus 19, and that is equal to 32. Now, in order to isolate the variable and get x by itself, we have to remove the addition of 19. Again, we do that using the inverse operation, which in this case is subtraction. So I will subtract 19. Now, because I subtracted 19 to this side, thinking of the balance scale and keeping it completely balanced, I need to subtract 19 from that side. Okay, 19 minus 19 is 0. At this point, we have the additive identity of 0. Using an inverse operation gives us the additive identity of 0. On this side, I simply do the math, and 32 minus 19 is 13. Now I can look, and this I can do because anything plus 0 is itself. So x plus 0 is x. I have met my goal and have isolated the variable, gotten it down to just x. And on this side, it is equal to 13. So I have found that x equals 13. Now, I do need to check my answer to make sure that I am correct. So in the original, whatever my x was plus 19 was supposed to equal 32. So I can plug that back in and find that that is in fact true. 13 plus 19 equals 32, whether you check that off to the side or on your calculator. So I know that I am correct here. Now, do another one. This time we're going to do a subtraction. Where x minus 21 equals 9. Again, my goal is to isolate the variable, which will not always be x, but in this case is. How do I do that? I need to undo the subtraction of 21 and then make sure to balance my scale, and I will isolate the variable that way. So now the inverse operation of subtraction is addition. So what I will do is add 21 to this side. I need to make sure to balance my scale, so I will add 21 to that side. Subtraction of 21 plus 21 gives me 0, the additive identity, which is what we want to get. 9 plus 21 is 30. X plus 0 is x, so we have that x equals 30. Again, I need to make sure that I am checking my answer. And in fact, yes, it does check. That's a very important step because very often we can make little computation errors that can give us a wrong answer. All right, this step here of always writing the identity is not one that we always have to do. So in a more simpler format, if I am going to solve this equation, again, it's a one-step addition, I need to use the inverse operation of adding 5. That is subtracting 5. And of course, I balance my scale. Now, one thing you can do, a little trick that I've taught my students in the past, is to put a z, because what happens here is 5 minus 5 zeros out. You would get that 0 there to get you x. So to skip that step, you can draw a z through those saying, hey, this is zeroing out. They're going away. They're gone. And what I'm left with is just the variable x, which is what I wanted on this side. Then on this side, I again just simply do the math, and 16 minus 5 is 11. So I have found that x equals 11, and again, I would still check my answer to know that I am correct.